Atomic size. So the size of atoms is important for the same reason that the size of ridges on the end of a key are important. They determine what locks the key can fit into and which locks it can interact with. Likewise, the size of atoms in a molecule determines what pockets that molecule can fit into and what other molecules it can interact with. For example, what proteins on the surface of a cell. Now, the trend for atomic size is as you go to the left on the periodic table, the atoms become larger, and as you go down on the periodic table, the atoms also become larger. So here it says which atom in each pair is larger. Are the atoms that make up sodium larger, or are the atoms that make up chlorine larger? So we'd want to see where those are on the periodic table. Sodium is here, chlorine is here. Because sodium is further left, it is larger. Sodium, the atoms that make up sodium are the larger atoms. Okay, which atoms are larger, the atoms that make up lithium or the atoms that make up rubidium? Where are they? Lithium is here, rubidium is here. Rubidium is lower down, so it is larger. Which atoms are larger, the atoms that make up potassium or the atoms that make up calcium? Where are they? Potassium is here, calcium is here. Because potassium is further to the left, it is larger. Potassium, the atoms that make up the potassium are the larger atoms. Which atoms are larger, strontium atoms or iodine atoms? Where are they? Strontium is right there, iodine on the other side of the periodic table. Because strontium is further to the left, the strontium atoms are going to be larger. Similar question, but here it says order the following elements from largest to smallest. The first one asks to compare aluminum, sulfur, and sodium. And here, this is a picture of sulfur hardening on the outside of what's called a fumarole on a volcano in Vulcano, Italy. Fumaroles are where smoke escapes from vents near volcanoes. That smoke is sulfur dioxide, and the sulfur hardens onto the ground nearby. So which one of these is made up of the largest atoms? Well, where are they? Aluminum is here, sulfur, and then sodium on the far left. Because sodium is the furthest left, it's the largest. Because sulfur is the furthest right, it's the smallest. So if you want to order them from largest to smallest, it would be sodium, then aluminum, then sulfur. That's the order of atoms from largest to smallest. How about chlorine, bromine, and iodine atoms? Ordering those from largest to smallest. So chlorine is here at the top right, bromine just below it, iodine just below that. Because iodine is the furthest down, it is made up of the largest atoms. Or an iodine atom is the largest atom of these. Because chlorine is the furthest up, it is the smallest of those atoms. So putting them from largest to smallest, first you have iodine, then bromine, then chlorine. That's the order of those atoms from largest to smallest. How about gold, copper, and silver? So gold is here, copper above it, silver in between. Because gold is the furthest down, it is made up of the largest atoms. And because copper is the farthest up, a copper atom would be the smallest atom of those three. So ordering them from largest to smallest, you'd have gold, silver, and copper. How about phosphorus, which is the red substance on the end of a match, silicon, and aluminum? Phosphorus on the right side, just to the left of it is silicon, just to the left of that is aluminum. Because aluminum is the furthest left, it is the largest atom of these three elements. Because phosphorus is the furthest right, it's going to be the smallest. So ordering them from largest to smallest, you'd have aluminum, then silicon, then phosphorus. Thank you for your attention.